Hello and welcome again to QuickType Inside Out, episode 5 this time, where we are still implementing C++ support for QuickType. In the last episode, we generated these type declarations for C++. And if you recall, I kind of said we're going to use unique pointer for the union types, but after some playing around, I decided that I'm going to go with boost optional first for nullable types, because I couldn't make this work. I couldn't make shared pointer work. I was too lazy to try for very long, and the boost optional just worked. And in any case, we're not interested in the C++ part here so much as in how to make QuickType generate code. And I'll explore the proper options later. I'll consult with C++ people, and we'll figure out the best way, or maybe a few different options to do this. So in any case, I will unfortunately depend on boost at first, and the way it works is that instead of having std unique pointer here, we have boost optional, and that's a pretty easy change here. So that should take care of the C++ type part. But what I promised last time was that we were gonna generate, so this is boilerplate that we're gonna insert later. This is required for the serialization, deserialization of the boost optional. So this is code that we can just copy in, basically. But I'm not going to do that now. That's just a distraction. The main thing that we want to do now is we want to generate these from JSON and to JSON overloaded functions for our types. And that should be pretty straightforward, because as far as I can tell, we're not going to have any special cases, meaning that no particular kind of type needs special handling other than what you see here. So for the from JSON, you just generate this assignment, and you get the property inside the JSON, and then you call get parameterized with the type that you want. And we already know how to generate the type. So I think we'll just start generating maybe the from JSON first. So as you can recall, we have this for each class function. And the way I want to do it is I want to have all the class declarations first, and then the from JSON and to JSON methods after all the class declarations. So we're going to make another for each class. We could, of course, emit the stuff right here, right? But then you would have interspersed class declarations and method and serialization, deserialization function declarations. And it's nice for the user to being able to see the types first, because they convey useful information to the user of QuickType, whereas the serialization and deserialization stuff is just stuff that just needs to happen somewhere, but it's kind of like it should rather be hidden. So let's do this again, and this time we are going to make emit class serializers. Let's just call it emit class functions. So this obviously, of course, is the same signature. Emit class functions, and we're going to start with the from JSON. So let's just copy this in here. So that we have a template, as it were. Now, this is always called from JSON. That's just the name of the function. It differentiates itself from the other from JSONs by the type that it's overloaded on. And this is the name of the struct that we declared, so the class name, basically. So we are gonna emit, well, it is a block. So see, now we're gonna use the emit block thing again, because this whole thing is a block, right? Curly braces, and then this is the first line in the block. So we're gonna use exactly this same pattern that we used here. We're gonna use this emit block, and this is what's in there in the first line, and this is the function that emits the contents of the block, the body, right? This stuff. So in here we have this, and of course this is all verbatim. Like all of this is verbatim pretty much, except for this, and this is the class name. And then this stuff, oh, we can just call it X. I don't wanna give it a name other than that. What is it? What doesn't it like here? Oh, yes, we have to tell it this argument, which is whether we want a semicolon or not. And we do not want a semicolon because there's no semicolons at the ends of function declarations. So now all we're left with is these lines, and of course, this is, you get one line for each property in the struct. So we're going to use exactly the same pattern as here. Namely, we do a for each on the property names. And what we have is, this again is the JSON. I'm sorry, this is the JSON name, right? So this is that. And this name here is the property name, which is this. So what we have to do is, we have to emit a line where we have x dot and then the name of the member variable in the struct equals j dot at open quote. And here now we need the JSON. However, this JSON might contain lots of weird characters. This JSON might contain quotes, like double quotes themselves, or it might contain new lines. It might contain whatever. But fortunately, we have a function called string escape, which handles most of that for most programming languages, and it doesn't handle some cases, so I should fix it and make it work for, make it parameterizable by programming language. But for our purposes, for now, it's enough. I know that in Go, Unicode escaping works differently, and I haven't fixed that yet. But it's one of the issues in our GitHub issues. But it should work for almost everything in, at least here in C++. And so we're escaping the JSON string, which is going to insert like a \n for new lines, and and / escape the quotes and stuff like that. And that is that. And then here we have to do .get, and here we need the type name. So this is the type name. Let's just const cpp type equals this .cpp type property type, except that Oh, right. So this is the CPP type. And then that, and that should be it. Yeah. Well, let's just try it and see what happens. So let's do it with, let's do it with GitHub events. Okay, we get lots of bullshit. But yeah, look at that. So that looks pretty good. Do we have one where there's weird property names? Probably not. There's lots of them in the test cases, but I don't want to go into that right now. We're going to see how to integrate the new programming language in the automated tests later, and then we'll see probably lots of tests failing, and then we'll have to fix those. So also note, we're going to have to fix this too, because we emit, where is it? Because we emit this annotation with any and null type, we also emit those annotations not only in the declarations of the structs, but we also emit them here in the class functions. But we typically don't want that. We only want, because we get basically two issues generated in, two warnings, if you want, for the same exact issue. So what I'm going to do, and I think I did the same thing in C#, but let me take a look at how I did that exactly there. We're going to add an argument with issues to CS type. Oh, I had maybe annotated, and where is that from? That's from somewhere. That's from source. Okay. So I have this function in source maybe annotated. So actually I don't need this, I need maybe annotated. And then I'm going to add here with issues, which is going to be false by default. So that we have to say, yes, we actually want an issue here when we're actually sure that we want it maybe annotated, and it takes the flag first. So it takes the with issues flag first. Why is that a problem? With issues. What? A parameter initializer is only allowed in a function or constructor implementation, but this is exactly the same CPP type. Oh, I see what's happening here. Okay. All right, let's not do that right now. So here's the problem. The problem is with, I'm just gonna put true in here right now. The problem is that this is not, so this is the function, this whole thing, right? This match type all returns a function instead of it being a function that you call. So it's a higher order function in that sense, and match type all, or the function that match type all returns, does not take that argument. So that's a bit of a problem. So what we could do, but I don't want to do that. We're going to fix. I'm not going to do that now. I'm going to do that separately because it has nothing to do with what we're trying to do here. It's just one of those issues that come up when you support a new language and you haven't done a specific thing before, and then you have to fix the infrastructure. What I'm going to do is I'm going to make match type all not return a function, but I'm just going to have it be a function that you call with a type as an input argument, and then this is going to be not the function that this returns, but it's going to be a separate function that calls this function. And if that makes no sense at all, don't worry about it. I'll just fix it, and in the next episode, I'm going to show you just what changed here. So in any case, then the next thing that we have is the toJSON, which, oh, there we are. toJSON, which is supposed to look like this. And this is a little bit different in the sense that it's just one line, and we have all of these parts in here. So what I'm going to do is I will make an array that is going to accumulate all of these parts, and then I'm just going to pass the array to a midline. And I'm going to show you what I mean by that. So we need a new line here. And so this piece is fine. This is another emit block. And again, it's basically almost the same, except that the const here is not here on the JSON, because the reason for the const is this is from JSON, right? So it doesn't modify the JSON, but it modifies the whatever this is. It modifies the struct. Whereas this is toJSON, meaning it doesn't modify the struct, it modifies the JSON. So I'm just going to copy this. So it's toJSON, and this here, and this is const. So that was easy. And now we just have one line. And so what I'm going to do is I'm going to do const args equals an empty array. And now we're going to iterate over the properties, and we're going to add each one of them in turn. We're going to push it onto this array. So again, same thing, and we will also, no, this time we won't need the types. So we just need the JSON names and the property names here. So this is, again, the JSON name, and this is the property name. Now, here's a difficulty. This has to be separated by commas. So let's first just add this, and then worry about the commas later. So all I'm going to do is I'm going to say args.push, and push takes any number of items that get added to the end of the array. So this is, we're going to add the same stuff that we would pass to emit line. So we're going to add quote JSON quote comma. Oh, and except that, oh, I did call it X. Yes, it's not P. So quote X dot, and then the name of the member variable, and this closing brace. And what does it not like here? Argument of type is not assignable to parameter of type. Never. What do you mean? I have no idea what that means. Maybe it's gonna change its mind later. Maybe not. Is it possible that args is a special name? Arguments. No, arguments is a special name. That is really weird. Okay, I'll figure it out later. So, but now the problem is that we don't have these semicolons in between. One trick that I use to insert these semicolons is I observe that there is a semicolon before each item in the array, except for the first one. And so what I do is I say if args.length is not 0, args.push that. That is so. Oh, I see. We didn't declare the type here. So this is actually, we should declare this is a source-like. And it's a source-like, again, because we're going to pass it to emit line, which likes to have source-likes. And source-like is defined recursively as also a string is a source-like, for example. Also a name is a source-like. But also an array of source-likes is a source-like. So all of this works. So now we have our array, and we should be able to just emit the line that says j equals JSON, and then the args, and then the close bracket or brace, and then that, and that should be enough. I think so. Well, let's give it a try. Alright, this is bullshit. So, href, x.href. Yeah, look at that. This looks pretty good. ID, xid, name, URL. Oh, well, of course we get these. And maybe we'll do something about that. The code should be correct, but it's really ugly. So how about we try this on a test JSON? Do I have like a very simple test JSON? And we could use Reddit getting started. We could use getting started. Sure, why not? So getting started is a it has a string and it has an array of strings, so easy enough. So let's generate code for getting started. Now this code, I'm just going to copy into my Xcode thing. And I'm just gonna override all of this. And I'm gonna delete all of that. I don't need any more. Oh, interesting. Unknown type name JSON. I guess that needs to be here. Yeah, okay. So all of these are things that we're gonna have to add to our generator, but it's pretty easy. It's just like a constant string. So now let's make a getting started. So here's how you do that. You actually just need to put in the string literal and prepending that underscore JSON thing. So we can just take where is it? This is the getting started string. Of course, this is not going to work because we're going to have to quote some stuff, but JSON J equals, so this is that. And then of course, this needs to be, oh, I see. Multi-line stuff, instructions, and I'm going to be lazy. I'm just gonna add a single one, maybe two, so you can see it's an array. Type or paste JSON here, or choose the sample above, and then we're closing that, and we're closing that, and we're closing that, underscore JSON. And that should work. So now we have a JSON, and now we can say person, not person. What did we call? Oh, getting started. So now we can just say getting started GS equals J, and that should work. And we can look at that in the debugger, but then we're going to go the other way. We're going to say JSON J2 because we want to see whether both directions work. We're going to convert it back to a JSON, and then we can print that JSON to stdout. And let's just see what happens. So this then should print that JSON. Look at that. That totally worked. And as you can see, hopefully, in getting started, we also have, oh, well, this is a vector, and we might not see its contents because it's complicated, and it's a string. Yeah. Data. I mean, yeah, let's not go there. But as you can see, it works. So the data has to be in there, right? Because we converted it from JSON to a getting started, and from the getting started to a JSON, and the JSON still contains the data. So hooray! We made basic stuff work. Of course, it doesn't. We've only used strings and vectors, so other stuff might not yet work. But we will find that out soon enough. So let's take a look at what we need next. We've already implemented classes, but we don't have union types that are unions of something that's other than null and one other type. And these will also require that we generate probably maybe either a union type or a struct type from them. I don't know. I'll figure that out. But that will be what we're going to do next time. But for now, I think this is pretty good. So yeah, there you go. See you soon. Bye.